All right, all right, all right. Here we go, round two. So basically, I'm just end up staring at this. You know what I'll do? I'll have this run fill with air. Let's see what happens. So bolt out of air. Good. Let's open this door. Nothing should happen. Good. This one should fill with air. Good, good. Let's close this door. Let's open this one. That should fill. Oh, look at that. It increased it. Ooh, why does it do that? Why does it increase it so much? How long is this set? Let's set this to 1 second. Fills up with air. Let's close that. That 806. Let's spread that. This is stuck at 908. What's causing it to do it this way? What's causing this here? It's causing it to close. And I open that back up. And it stops. It stops draining air. So what's the deal here? What am I missing here? So air fill up is false. What I should do is maybe I should take this and attach this to this process instead of having two separate, because they're really two sides of the same coin at this point. Air fill up is true. You know what? Maybe I need to rethink this concept here. I need to rethink this concept here. So what's going on here? This needs to go here. This needs to go here. Let's get rid of this. Event tick. Air fill up is false. So while it's false, it's taking the air out. Well, really, they should both be going. So let's try a different idea here. It's always taking the air out. As long as the fire is active. Fire is active, take the air out. If the fire is not active, it doesn't really matter. As long as the fire is active, take the air out. Also, we'll do a sequence. So as long as the fire is active, take the air out. At the same time, if the air is less than the max air in the room, if the current air amount, room air amount, is less than the max air possible, is true, then search the array, loop through the body, and get room air each one for each, and divide that. And it doesn't really need to be that percentage. It needs to be how do I get this to auto balance the air? It needs to be room air is less than the max. It's true. Loop through the other bodies of air, including the outside air, and we need to balance it. I think this is right, because this gives me a percentage. So instead of this, I think this is okay. The current room air is greater, this percentage is greater than that percentage. This percentage is greater than that percentage. Then so if this percentage is greater than this percentage is true, set this room air, let's take this room air amount set room air amount. Set this room air amount to this room air amount minus 1. Okay. And set this room air amount to this plus 1. Okay. Right? Alright, so it's going to minus from, let's say, outside air 1. And it's going to add to room air 1. Okay? So that should work. Let's look at the begin. So it's going to minus from there until it's out. However, let's add another variable. Outside air. Let's make that an exposed variable. Let's say, let's do a branch here. And let's say it's outside air equals false. Okay? If it's true, we're just going to set this to the max. So this will all be set to max. Room air amount. Rather than that, let's set it to like, I don't know, set it like every second. We'll just set it to like 10,000. Because I never want it to run out. Let's set it to something traditional. 9,999. Okay, so let's make this one. This is outside air. Okay, so if it's not outside air, every second it goes here and checks to see if it's fire. If there is fire, it removes air. Okay, and if it's either way, it always checks to see if the room air amount is less than the max air. If it is, then go ahead, loop through the body, get the room air amount of the other ones in its connection. Max room air divided by is greater than the room air amount. just to ensure that that's not an issue. That way that's always 1 to 1. Okay. There. And so this should always be 1. If that's greater than whatever, half or whatever, it's true. Then minus 1 from there, and add 1 to there, and check backdraft. Okay? And it should, when it's completed, it goes back and checks repeatedly. But this is going to make it check a lot. So I think I stop this. So maybe this should go here. This should go through here. No, because that'll check repeatedly. This is going to go through here. Every second it's just going to add 1. I want this to add repeatedly. Not sure about that. So if I tell this to execute, this is going to delay, but this is on that tick anyway. I don't know if that's actually going to matter. Let's see what happens. Yeah. Okay, let's open this door. Interesting, so they're adding to each other, which is not possible. Air fill up and air fill with air. So that's shouldn't matter. How does it know the door is open now? How does it know the door is open now? That doesn't make sense. Alright, so these are both going down. Now that I've redone this whole script here, they both run out. Look, they're filling each other up. That doesn't make sense. They shouldn't be able to fill each other up. So what's happening is these are not coming off, but every second this is filling up. So if this one's greater than that one is true, then it's doing this. It's minusing 1 from here and adding 1 to there. But because they're linked, they're cycling back and forth. Oof. What's the deal here? How do I make that stop? because they're not exact. Maybe I can make them exact? I think I have to do that. Because otherwise they're just going to continue to fill each other up. So how do I make this exact? Is it absolute? Is that what I need to do? Returns absolute positive? No, because those are negative. I need to round this out. Maybe instead of float, I should convert to an integer. Let's see here. Yeah, here we go. Rounded integer. I think that'll help. Because they're just cycling back and forth because it's never exact. So now they'll be able to hit an exact number. One of them's going up, and the other one's not going down. And half worked? That's frustrating. Let's check that again. So room 1 is building air. How is room 1 building air? Because it's down here. It's getting it. This one is not on the cycle because this room air is not more than the max. And there's integer. I wish I could think of this immediately. So the problem here is that this is still filling with air because this percentage, I should do, I guess I should reverse it, I suppose. Let's throw in a false situation here. And this will so this will -1? I don't know. I'm getting confused. Let's try this. Let's see if that creates the right flip. So they're both out. $87, $86. This is going up. Still, room 1 is taking priority, and it's just pulling air from room 2. That doesn't make sense. And look, room 1 was able to ignite itself again. Now, room 1's doing it again. I don't understand how it can be pulling that way. It's gonna ignite again. I don't understand how it's doing greater than 1. That's crazy. And it burned itself out again. What am I doing wrong here? I gotta be doing something wrong here. Alright, let's look at this from the beginning. Every 1 second on this 1 second tick, outside air is false. This is not an outside air piece. Go through here, and if there's a fire, and the room air is greater than half of its amount, then subtract air from the room. Alright, so that's all that. Okay? Meanwhile, during that same second, room air amount is less than max room air. True. So we don't need this anymore. Go ahead and check all the other air and see if the room air amount, so room air divided by max room air, that should give me a percentage, and round to the nearest integer. Same here, is greater. I wonder if it's got to be something to do with this statement here. If it's greater, true, go ahead and pull from the greater one. Let's just see if somehow I got these backwards. Let's flip these. Alright, they're out of air. And it's still wrong. Now room 2 is having that advantage. So that had nothing to do with it. It's got to be the math, the function here. What's another way to define this? How do I get these to balance? How do I get these volumes to balance? What's another way? I guess my math isn't precise enough, or doesn't make sense, because they're going to have different volumes and they need to get to the same percentage, and this should return a percentage. Let's break this for a second here. Let's go ahead and print out what we're actually getting. Let's change the color here so we can see it. 1 second, and let me see what I'm actually getting here. So 1's coming back as 1. So, kind of doesn't make sense. So this one outside air, and this one is using room 1 air. maybe that's why I need to have all of them in here. I think that's my issue. This one will just have room 1 air, because that's its only connection. So maybe that's the real issue here. Let's try this nonsense real quick again. Oh. I think I know why now. Because it's checking this. It's not checking to see if it has access to that room. It would have to have access to that room, to that space. That's the deal. It always has access to there. That's the problem. So it needs to decide if the door is closed, it doesn't have access to the outside air. And how do I do that? How can I tell it that? So if this door is closed, then this needs to know that the outside door is closed. It needs to know that the outside door is closed. Okay. How do I do this logic? If I make it so this outside door is, maybe I can tell it that that it's an outside door. How do I do that? How do I tell it that this is an outside door? Make it so all the other doors know. All the other air knows. So it just needs this. The primary room needs to know where the outside air is coming from. So if I tell it to check to see if the door is open, it'd be better if the door told the room that it's open or shut, because otherwise it would be checking every time. Yeah. So this would need some sort of variable to know the doors. So I need to set a variable in here that's tracking, that knows if it has access to outside air.
What is it with you rock and rollers? You can perform for 1,000.
So how could I do that? Well, if this door is open, which is kind of what I was doing here. It loops through the air boxes that it has available, which in this case, it's room air 1. It loops through that, tells it that it's open. Originally I had it called air fill up, but let's call it door open. Okay, and what it needs to do here, is let's approach this one at a time here. So let's go ahead and change this. Let's change this to half the size. Okay? So now this is going to be half the size. 250 to 900. Okay? I think I want to add a little more detail here. Let's go ahead and append a little bit more. And let's add room air mount and max room air. Let's divide these so I can get my percentage here. And let's drop that right there. So now this should tell me, yeah, this should tell me a percentage. That's at 1.0. Perfect. Okay, now let's go over here. And let's enable the fire again, I guess. And instead of this being in there, let's go ahead and pick these fires. Move them out of the room. This is quickly in a negative state. And look, it's pulling from there. It shouldn't pull from there because of this. Okay, so that stays at its 0.2 ratio. Alright. Alright, let's go back. Room air mount, but is less than max air. Okay. Let's also do one more thing here. Let's set the room air mount, if that's false, to the max air. That way it can't go too far over. I don't know. That's fine. Okay, and then it looks at the shared air array. So this has two shared airs, which is outside air in room 2. But if the door's closed, it can't do anything. So I think I need the air to have a doors array. I think that's what needs to be done. Let's do a connecting doors array here. And let's go to BP door base. Okay. Let's expose this. And let's make it an array. There we go. Okay. And now this will have an array of what doors are connected to it. So we're going to have two doors. We're going to have this door. We're going to have this door. Okay. For now, let's give it some good names like out side door. That'll be a little easier to track, and this one will be inside door. Right. So now it knows that it has these doors. So what it should do now, it'll check now it'll check the outside door. Is the outside door open? Yeah. So it'd actually be going through the outside doors array. How would it know that? It would go through the outside doors air boxes. Right? That's room air 1. Is that right? So I'd add this. So it would check with the outside door. Oops. It would check with the outside door. Well, this is maybe being too complex. It checks the outside air. I think it needs to check the door first. So it needs to, oh my gosh. Let's move this down. We'll probably need to throw some stuff away later. Let's make this, because it's kind of annoying. Let's collapse this. There. That way that's done and out of the way. And then, so it needs to check the doors that are connecting to see if they're open. But that was the thing I didn't want to do. I didn't want it to check every time. I didn't want it to check every time. I don't want to program a door for every single opportunity. I want to be able to have it detect what's going on and just do some settings. Because if I have it check the door every time, that's a lot of casting. That's unnecessary casting. So the door should pass a variable in here that it doesn't actually have to check anywhere else. So how can I have, is it this? Is it a map? It might be a map. Yeah. So this would be a map with a boolean. I think that's what it needs to be. So it's gonna check these. So when the door's here, the door goes through its loop array, and it goes to set connecting doors. I really don't know how to use this. Connecting doors. Map view based on its references to booleans. I'm not sure how to use this. That's unfortunate. Because I think this is what I need here. This doesn't let me set that. Let's see. The set. Here's my variables. Actor. Base door animation. Collision. Default. Door set door opened. That's a different variable. I don't know how to use this. Let's do, I guess, some research here. Yeah, array map. Pause this music for a second. Check this out.
Tomatoes?
Hello, welcome to video 4. What is the map variable? The map variable was introduced to Blueprints earlier than 4.15, but only for editing purposes. In 4.15, we can actually create maps in the editor, and we'll cover what they are and what they do. Maps are basically like a structure that can contain two things, and they are related and linked to each other. That's probably the easiest way of thinking about it. Maybe even like a two-dimensional array. But they are symbiotic. Basically, they are linked to each other, and you have a value and a key is how it works out. The key is unique. The value is what the key is pointing to. So let me show you basically what I mean by that. If we go over here and we'll create a new variable, and we'll call this one our new var. And we click on this drop-down list, we now have a few options. Before we could toggle between the variable and maps or the variable and arrays. Now we have sets and maps. You'll notice I cannot change this into a map. Booleans and a few other different variable types, text would be another one of them, cannot be set properly, not text. One of these other ones, new var. Basically, if it's got a value that can be directly referenced, so things like, but here values inside of here directly mapping. And you notice when I hit plus, unlike an array, it won't let me continue. It says it couldn't add it because there's already a default value. Remember I mentioned that the keys are unique. Right now it's treating this key of nothing as a valid entry. I cannot have more than one entry with nothing. I'd have to have something like an apple. Now I can add another entry, and I could have something like a pear. And you could continue on. And you can directly reference things. So this could, for example, could be an orange. And I could say I have 10 apples and 5 pears and 4 oranges. Now I have a direct correlation inside my map. I have a key, apple, value 10. Key, pear, value 5. And I say keys and values because those are the things you pull out, which we'll see down here. So for my example here, if I hit play and I hit make potion, it's going to tell me make potion 1. I hit make potion 0. I hit make potion and now it says missing ingredient. Basically what I'm doing, if we look at our player's inventory, is we have some ingredients. 1 bottle, 2 herbs, 5 potions. And we're checking to see if we have herbs in bottles. And then we're removing things from our inventory over here. Basically I'm saying, hey, find the key with the name of herb and give me the value. Find key of bottle and give me the value. seeing if I have any of those. They're greater than 0. And if I do, I'm going to go ahead and make a potion. If not, I'm missing an ingredient. And then after I'm done, since I'm going to reuse the bottle basically, I'm just going to get rid of my herb. Now that's one thing to note here. You'll notice that I'm using the add node to change the value. Because these are unique, the add node is how you can store and update a value. You'd basically plug in our inventory, which is our map, tell it which key we're going off of, in this case the herb, and tell it what our new value is. And I'm simply grabbing our old value, subtracting 1, and setting it. So that's why it's basically able to check. So it's basically a relational database, or a list, or a dictionary. In terms of nodes, we have these nodes right here, which are pretty simple. We have the length. First, one thing to note, most of these nodes are going to be very similar. I honestly don't know the difference why you'd use contains other than find, unless it may be quicker. Contains takes in our map and our key and outputs if it was there. Find does the same thing, takes in our thing, adds our key, outputs if it was there, and also outputs the value. So the difference between the two of these, I don't. Let me plug this one here so you can. This basically outputs values, because technically when you get all the keys, you get back out an array of the values. So this will give us back all the keys in our map. Here we don't take in a specific. Again, we'll go ahead and clear and give us a blank map. It's really easy in multiplayer to the widget for that player in a.
Okay. I'm not sure I fully know a big difference of what I just learned there or not, but let's give it a shot. Okay, so what I need to do here is add I didn't do it. That doesn't seem to do it. That's not it. I don't get it. How do I change this value? Connecting doors. Let's add one here. Base doors. It's set to false by default. And let's get this. Get copy. I don't know. For each. Not really clear on how to get this thing to output its data. Find by reference. Value, boolean, return value. Value, the value associated with the key. If true, if an item was found. False indicates nothing. The map uses the provided key. Here's the map. Find within that map. The key that will be used to look up the value. So is that where we do this? not really clear here. What were all the options he says are available? Link contains keys. Let's go to keys. Oh boy, let's get in some new territory for me here. Oh, okay. So, connecting doors. Keys. Okay, so find the key for the connecting doors. In that array, find its value and output its value true or false. Let's go ahead and break this and make this a printout so we can get some data first. Open. Closed. Actually, we should really do a pinned here. So this will be is closed. And let's do this over here. Is open. I don't know if I got that backwards now, but whatever. All right. So now, if there is less than that, it's going to look through the keys inside here, then loop through there, and find the door, and then look to see if it is condition is true or false, and output that. Okay? And the door itself will broadcast that. So the door itself will broadcast its status. For each one, each airbox, it's going to go to the connecting doors. And add self to its status. Oh boy. Let's give this a shot. What? Oh, this. I just do that? Yeah, I can just do that. Okay, come on, baby. Oops. Is open, is open. No, it's not open. Well, whatever, I have it backwards. That didn't work. Oh, you know what? I didn't actually add it, did I? Come on. Still says it's open. It's not a good sign. Shh. So this didn't work right. Oh. I didn't loop that. Throw that in. Still says it's open. It should, by default, read. Now it's closed. I have it backwards. Yeah. So that's all. Doot. Doot. That doesn't make sense. Yeah, it does. Is closed, is closed. Yep. Let's open the door, and now it reads open. Now let's close it, and it reads closed. Perfect. Now it's not sending it every single time. It only sends it when the door opens and closes. That's beautiful code right there. Oh, baby. And I learned something new. Whew. Beautiful. Oh, okay. I love that. That's beautiful. So now it knows if it's open or closed. So this is closed. So, if it's open, here we go, round 2. If it's open, go through the shared air of other ones it's connected to, which in this case is outside air and room 2. And it's going to wait a minute. Wait a minute. That's not quite right. It's not quite right because it's still going to go through all the air. So the order might need to be switched here. So I think it needs to do this first. So what I think it needs to do is it needs to grab this. So it's going to go through all the open rooms, right? For all the open rooms. Let's move this out a little bit further. So it needs to go through all the open rooms. That's probably not the best way to do it. The logic's wrong here. Logic is wrong. Because it's going to go through the room. It's going to go through outside air. And then it's going to go check the doors. And when it checks the door, it's going to the outside room and check all the doors. It's going to go to the outside. It's going to check that air. And then it'll go through the doors and see if that door is open. But it doesn't know which door is connected to which one. So that's irrelevant. That's irrelevant. What am I missing here? What am I doing wrong? I need it needs to be in this room. It is checking. It runs out of air. When it runs out of air, it's always checking for fresh air. So, does it have access to fresh air? So it has to, first of all, it has to see if it does have access to fresh air. So if a door is open, then maybe it can check this door's air boxes and grab this array. So if the door is open, then I'll go through and cycle through this doors array and see if it has any room with air. Is that right? Alright, let's try it this way. Seems a little funky, but let's give it a shot. Since I know this works, it's going to go through here. It finds a door that is open. And when it does find that open door, it's going to check that open door's what do I call it? Air boxes. It's going to check this open door's air boxes. Okay. And it's going to check that. And then it's see if this open door has air to share. I don't know. Seems funky. Let's try it though. I'm gonna go delete this one, just so I don't have to deal with watching it. Look at that. It's adding air. Excellent. So that part's good. It's adding air super slow, which is not what I wanted. What I should do is not a tiny amount, but rather a percentage. So let's pull this off. Let's only do one piece at a time. So, this should add, it should minus a percentage. So how can I do that now? How do I get that to do like a flow? Or I could just make it faster. Like I could put in some sort of stupid loop here that goes like this. Really needs to go back through this, unfortunately. It really needs to go all the way back through here. Oof. Let's see if that makes it faster though. Open door. Much better. And it just got to half. So why did it just get to half and stop? see here. That's there. And it got to half. It stopped. Why would it get to half and stop? So it gets here. That door is still open, obviously. Room air amount is less than max room air, which it knows it is. Okay, so it goes on here, loops again, checks that, goes over here, and moves that. Why would it get to half and stop? Let's remove the backdraft. Maybe that's causing something. Let's let it extinguish itself. Let's open the door. Let the air come back in. And it got to half again. So that has nothing to do with it. The backdraft had nothing to do with it. Okay. So why is it getting to half and stopping? Obviously something to do with some other thing I have here. Is it because let's see. Let's make sure that this is maintaining air. Let's open this sucker. It should be draining, draining, draining. But that stays at full because it always does. So this stays at full always. So that's true and it's going to stay true. Okay. So why is it getting to half and stopping? Let's see if I make this to like 75, if it changes that. Let's see if it has a correlation. It's not adding more air. So there's no correlation there. This is a different reason. Is it because this is greater than that is true? Do that. Let's see what happens when I tell it it doesn't matter. Up, up, up. The fire extinguishes it faster than that can do it, but why does this matter? So this So this here, this array, airbox array, so is it because it's checking itself? Because the door is checking room 1 and outside air. But if I don't have that in there, the door doesn't add those to the connecting spots. Oh, you know, because it's a third party now, it is checking itself. So it's catching itself. All right. Is not equal itself. Let's try that. Oh, disconnected. Okay, so it's not equal to itself. Then go ahead and do that. Let's see. It's building back up. Up, up, up. It stopped at half again. Why is that? So this doesn't make sense. I don't understand why I'm having this issue here. Room air amount divided by that. That should give me a percentage. Let's see what we get out of this. It's 0 and then it hits 1. Oh, it's probably because of this stupid idea. Still coming back as 0. Oh, because it's false. Okay, so it was related to that. don't understand why it's coming back as 0. That shouldn't come back as 0, although it is working. Must have something wrong here. Some sort of conversion. I think it had the integer still set in there. That's gotta be why. Yep. An integer conversion going on. And there you go. Okay. Thank you. Okay. So that's good now. I don't need it to tell me that the door is open every time. So let's go ahead and we don't need that. We don't need that. There we go. Let's bring back air. Yep. Beautiful. And then it loses air again because of the fire. Perfect. And it brings back air. So that's good. So maybe I can take this air amount and multiply it by this number and use this as the plus and minus. I don't know. Let's see what that does. That seems pretty good. Close the door. Oh, baby. Look at that. That's science. That is science. Bam. Okay, so now it's using plain air. Oh, I hate that I had to go backwards to do this. Alright, now let's go ahead and do the second one. This will be a beautiful system when it's done, but for right now it's frustrating. What was this, 9.5 for everything, I think? Yeah. It's not actually crucial. This is more for like, yeah, that's not crucial. Whatever. Okay. Okay, so that is room 2. And shared air is outside air. Brutal. So this one will be room air 1, and it has no other air. And this door will have room air 2 and room air 1 and room air 2. Okay? Room air 1, this has that. This has room air 1 and 2. Alright, so let's take our fires Move these back inside. And let's move our player over here just to get things started. Let's play with this one variable at a time. Let's move this out so that way these don't affect it. So this runs out of air. Okay. And it's staying consistent. Perfect. Now if I open this door, look at that. It used up the air from both rooms. Now, room 2, it's burning up both their air. It's kind of going back and forth though. Interesting. But that was the goal. Burn up both their air. And now that one should stop. Yes. Wow, okay. Now let's try this crazy experiment. This should burn up its air. Right? Let's open the door. It temporarily ignites until it burns up the air again. And please God, let air come back in here. Air come back in there. Interesting. It did work. Oh, that is beautiful. That is beautiful. All right, let's go ahead and close this door. And now it should burn up the air again. Yes, it did. Woohoo! That's awesome. It sucks air from both rooms now. Yes. Wow. That's amazing. All right. Let's increase the complexity here and get this one to register that air. Who knows what that's going to do? Honestly, I don't know. This will burn up its air. Okay. Let's open this door. Now it sucks in its air. Burns up both. Now let's open this door. And it should respond the same way as before. Yes. Wonderful. Okay. Now, let's increase the complexity one more time. And let's bring this fire into this room. They should both run out of air. Yes. Okay, let's open this door. It has nothing to contribute. That room contributed to this one, right? Because that one actually has, I gave it bigger volume. And then let's open this door. And that should ignite, yes. And that should ignite in a moment. Yes. Oh, that is just so beautiful. That's amazing. What a beautiful system here. So this one's having trouble staying lit because this one's using up its air first. Fascinating. Let's close this door. Watch these guys burn out all their air. Wow. That's it. This is simulating complex fluid using a few lines of code. What an awesome thing. Awesome. All right, let's go ahead and let's put in its real size. Just for fun. Oops, this was 3. Okay. They should burn up equally. There we go. Let's open the door. And they should have nothing to contribute to each other because they're equal. Right. Let's close this door. Go over here and open this door. This one should get air now. Yes. It has air. Beautiful. That one's staying the same. Alright, let's open this door. Make it air. Wow. What a beautiful system. Honestly, I feel ridiculously accomplished. This was an idea 2 days ago, and in a few hours of a fairly complex air fluid system here. Beautiful. Wow. So now the big room can create a backdraft in a small room, and open doors can create an issue. That's what I wanted. That's what I wanted. And it's very low CPU usage. Beautiful. All right. Wow. Okay. That's that. All right. That's the end of this one. That's everything I need to do. So now, basically, I implement this into... It's already implemented since it's sharing the code. All I have to do at this point is go over here. Actually, I'm going to copy this sucker. Go over to my test map. Okay. I got to put the outside air. You got to come over, buddy. You're the outside air. Okay. It actually doesn't matter where it is, but whatever. I put it here just for the sake. It is checked as outside air. So this door is getting, it needs to be connected to outside air and air 2. I'm not sure when I do these sub rooms. I suppose I just need to connect this sub room to this one. Okay. And this needs to connect to this one. And this one needs to connect to that one, which it is already. Okay, now this door needs to connect to this one. Forgot. Let's go look at my test map here. This is connected to the both rooms. Okay. So this door, outside air room 2. And this needs to be connected to both of these, so they trade. And is this the modern door? Did I update that one? Yeah, I did. Alright, so this needs to be connected to this one and this one. I think that shall do it. Let's give this a try. Why am I getting negatives? Oh, they burned out the air already? Because there's so many more fires here. I need to change the variable. I burned out the fire almost instantly. Gotta do one more check here. And a change. Room air amount is less than 0. Set room air amount to 0. That'll prevent that from happening. And then the fire itself. I don't think that matters. It's this here. There's a multiplier in here. Where's the multiplier for the fire? Where is that? That's not there. Where's the multiplier for the fire? Oh, right here. I have it at 50. I think it was at 0.5 originally. There we go. So theoretically, if I close this door, these will burn out. That one burned out over there. This will burn out soon enough. This has a lot more air in it, but more fires. Buzz it. There we go. Bam. And now, boom. Oh, brutal. Okay. So the other thing is, you can't just use that to extinguish, because what I want to add is, I want to add a situation where the player can, the people can pass out. Now this, gotta wonder why that didn't. Maybe this has to be. Let's connect the door to this one. Maybe these multi-volumes require the door to be on both. Like that. Let's give it a shot. Okay, let's test this out. Let's open the door. We gotta close it. Close the door. Let the fire extinguish itself. It'll take a couple, like 1 minute. This one should extinguish itself or get down to the low moment sooner. Yep. So now this one is ready for backdraft. You open that door and expose it to fresh air, it will backdraft and knock your guy out. These ones are down. Okay. Perfect. Alright. The other ones on the outside should be down too. Alright, let's go ahead and open this door. And bam. Air's in. Making it a nightmare. Oops. Let's get through here. So yeah, you can't just close the door and let it suck up all the air to extinguish itself, because the people inside will they'll suffocate. So that's the next step. I'm gonna make it so when there's not enough. Oh, perfect, that worked. Now those backfires lit up. So I'm gonna make it so that when there's not enough air in the room, as indicated by these numbers over here, the people inside the room will pass out. And you'll have to, I don't know, if I want to make it so you have to, if you can resuscitate them, at the very least you're gonna have to carry them out. So I just recently optimized these fires and got 15 more frames per second, which should be really good. Awesome. Come on guys, let's get out of here. You too. Oh. Let's go. Let's get you guys out. Oh, that one almost died. He almost died. Alright. So now let's go experiment with the backdraft. Let's switch to the wide spray. I made it so you can choose 3 different nozzles before you go to the mission as kind of a tactical thing. So you have the wide, the medium, and the fine. And the fine gets 1 fire at a time, but more effectively. This one can get 2 at a time, and then this one can get 3 at a time. But obviously the water amount's the same. Alright, so let's open this door and watch it blow up. Oh, baby. Now I'm going to make it so it does damage. There's no damage to you right now because of some other stuff I did, but wow. I can't get back there because the door. Oh, look, it's suffocating because the other one's pulling so much fire. That is fucking brilliant. Alright, this is the last play I'm doing. I gotta go do something for fun. I mean, this is fun, but I gotta do something that relaxes the brain. Okay, power's shut off. Now I should be able to get to these guys. Oh, there we go. Oh. Not much room and not much air in here. These people would be all passed out. Wow. And you are freaking trapped now. Look at this. Because the door was open, these fires just kept spreading. I gotta put another script in here that slows down the fire spread and increases the fire spread depending on how much oxygen is available. But that's coming later. That's beautiful. Let's take one quick look at the firehouse, because that's fun. So the firehouse, I'm gonna make it so here you can go choose your suit. Your different suits give you different, like here's the heavy suit, gives you more protection, but you can't really go very fast. But you should be able to walk through a fire with that. Medium suit, you'll take some damage, but you can actually kind of move. And the light suit, you can get going pretty quick. Alright, so let's go down here. Let's go down the fire pole. There we go. Not perfect yet, but getting there. And then this will be where you can choose your hose. I haven't done all that yet. And I want to make it so that you'll have a dog. You'll have a firehouse dog. This goes out into the world, into the mission. Here's your office. You can go up the stairs, of course. And I think it'd be fun to put some little games in here. Oh, I didn't make it so it reinitializes, so you can only do it once right now. Oh, I better fix that. Well, it's all part of the testing. Alright. GG.